joining us. Welcome to the lecture series on BEM theory and engineering applications. And we are very lucky that we have our speaker, Professor Youssef Rashed from Cairo University, will give us this series lectures. And today we started the first lecture, and I think Professor Rashed will introduce us the BEM. Okay, and so now first maybe I give very briefly introduce the Professor Rashed. So Professor Rashed received master and PhD degree in the development of boundary element method, and now he is a full professor of structural engineering in Cairo University, and then he is also the head of the boundary element research group. And also Professor Rashed published over 150 international publications, and he also is the main developer of the PLPAK software package. I think this software is a boundary element method software. Okay.
Yes.
And then I think I give the stage to the Professor Rashed.
Okay.
To introduce us today's lecture. Okay.
Okay.
So thank you. Yeah.
Okay. Thank you, Professor Fu. Thank you, Professor Fu, for allowing me this chance to present boundary element lectures to Hohai University first and to the international community as well. Really, I have to appreciate this chance, and I knew Professor Fu is very active in doing these workshops, tutorials, all of these things. So we made use of Professor Fu to push us to present these lectures. Especially, I didn't see a full boundary element course on the internet actually to attract researchers and engineers to use boundary elements. So we have the chance now to do that. Thanks also Professor Fu for presenting this very nice logo about our lecture series. Our lecture series we will have something like at least 15 to 20 lectures. Maybe we'll extend them after that. But we'll cover the basic idea, including the mathematics, the numerics, everything we will have. The best thing I have done is these are my contacts. If you can see on the screen, this is my email, this is my phone number, mobile phone number or cell phone number. I have WhatsApp on this phone number, and I have also WeChat. I put the WeChat because throughout the coming week, any person can send me a voice message, screenshot or something like that, asking me something, and I will reply him. Also, I will put these answers on in the coming lecture at the beginning of the coming lecture. I have also Skype account. It is Youssef.f.Rashed directly. Okay, let me give some introduction first. You can see that screen now. It is in front of you, the screen. Is it okay? No, I think it's okay, right? Okay. The course itself, we will start with one-dimensional problem. We'll start with one-dimensional problems. The easiest one is bar element. The bar element, it has only uniaxial displacement. This is the easiest one. So we can explain a lot of ideas, a lot of basic ideas we use inside the boundary elements. We will convey everything, almost everything inside the boundary element on this bar element. We'll take something like 2 lectures in this bar element. Then we will move to higher dimensional problems, as I am saying, like 2D problems, 3D problems, including scalar type, like potential problem, and elasticity, and plates and bending. Okay, when doing that, we will cover mainly 2 or 3 main aspects about boundary element, because we always say it is boundary element methods, not method. So we will cover the indirect formulation. We will cover the indirect formulation. We will cover the direct formulation. And we'll cover the variational formulation. Actually, indirect method or direct method, mainly we have a lot of methods inside them. For example, in the indirect method, we don't have indirect boundary element only. We have also meshless version from it. We call it method of fundamental solution, for example. We have something called fictitious stress method. We have something called displacement discontinuity method. We have something called distributed dislocation technique. In the direct method, we have also series of integral equations, like hypersingular integral equation. We have series of different types of integral equation we can use. Okay, we will cover all of that. In variational formulation, it is very similar to finite element formulation. But the last step only, instead of using trial functions, we use fundamental solution instead of the trial functions. Okay, so this area is very, very, very fertile, as I say, and I think Professor Zhuojia, who started this formulation, and he's very, very active in this area, and this is our role to continue his work in this area. Because of that, we will end up, after this, we will have to talk about coupled problems. I would say it is coupled to problems. Something like dynamics, inelastic problem, inclusions, fracture mechanics, and so on. And we will need numerical techniques. Not the traditional numerical techniques, something like evaluation of integrals or numerical integrals. No, we will need something how to deal with singular integrals, how to deal with hypersingular integrals, how to play with the integral equation itself. So I will start today mainly with the one-dimensional problem, and I will take 2 lectures. The first lecture in the one-dimensional problem, I will cover the solution in the differential form. Then in the second lecture, I will cover the solution in the integral form. Okay, great.